All right, I think I can hear me. Let's go. All right, I can hear me. Sweet. Now, don't be playing the YouTube. Put these away. I would brag about it being the fastest one yet, but I know I'm just setting myself up for failure if I do that. So I'm just going to be quiet. 11:02. I couldn't resist. Had to brag. And I have verified that the audio worked. At the moment I was verifying the audio worked. That's what I know. Who's ever driven a car? Who's ever driven a car? Who's ever driven a car and been behind another car? Some of you may have only won the race. Some of you may have never had to follow in the race. All right, driven a car, been behind another car at a red light, and the left light at the back of the other car is flashing. Who's ever experienced this? Everybody? The left light at the back of the car is flashing. Obviously, you don't drive in Massachusetts often because using the blinker in Massachusetts is a sign of weakness. But when you're in that condition, you're sitting there, car in front of you, left light doing this, flashing at you, sort of indicating. Wait, they call that the indicator light? It's indicating something. What do you know at that moment when you see that light flashing? What do you know?
They might intend to turn left.
So he says they might intend to turn left. That's the other driver we're talking about that might, right? Is that what we actually know? Do we have evidence of that? I mean, that light, we know the car manufacturer put that light there with the intent of allowing the other driver to indicate to us what they intend, right? But when all we have, the only data point we have, I guess the only data points we have are that there's probably a car in front of us because we're visualizing it. We see it in our mind, hopefully coming from our eyes. There's probably a car in front of us. And the filament in that light bulb works sometimes, right? We know that sometimes that light works and sometimes it doesn't. It could be that they're stepping on the brake and there's a bad wiring connection and they're vibrating at just the right frequency that sometimes the light's on, sometimes the light's off, right? So I know that at the moment I checked, the audio was working and the people watching from home could hear me. But that's all I know. Actually, no. I know that the people watching from my phone could hear me. All right. But today I want to talk about design for manufacturability. So I said at the beginning of the class, I promised you that this was not a design class, I think, right? It was an engineering class. And we're going to talk about manufacturing. But that we as manufacturing engineers, when we get to this class, we put on our manufacturing engineer hat, that we're not the designer. The designer is responsible for, what is it? The design part, right? So they're responsible for deciding what the shapes need to be, deciding what the material needs to be, deciding what the surface finish needs to be, and deciding what the tolerances are, right? That's the designer's job. We as the manufacturing engineers need to interpret the design And what they give us is the art. We call this the process of going from art to part. And so we're interpreting what they've designed. So I told you that at the beginning of the class, that this is not a design class, right? We don't do CAD in this class. We do CAM, computer-aided machining, computer-aided manufacturing, but we don't do CAD. Yeah, so for today, that's all bullshit. Today we're going to talk about design. I'll get my coffee cup out of your way. All right, so today we're going to talk about design. Who does design? The designer, I know. But who in the room figures that you're going to have a job where you design stuff that later gets made? Raise your hands. Be proud. That's a cool job to have. A lot of people that come to WPI are expecting that job when they arrive here. All right, and who in the room would respect somebody that had that job or wanted that job? All the hands should go up, right? We should respect each other. Okay, good. Show a little mutual respect for each other, right? So it's a valid thing to aspire to. I used to do this thing at the beginning of the term where I'd pass out index cards to everyone in the room, right? So everyone in the room gets an index card, and there's some questions you have to answer, and write your answers on the cards, and you hand them in. And the first day, I used to do it in every class. And I would go through, I'd read the results of the index cards. Sometimes the question on the card would be, was yesterday's lecture a total waste of time, yes or no? You know, check yes or no. Because I thought you ever think sometimes you did something and you didn't do a good job? Yeah, sometimes I have that thought. Sometimes I do crappy lectures. I try not to, but it's hard sometimes, especially this part of the term. Everybody's tired. This time of year, everybody's tired. All those things. Anyway, I asked in the class, I said, why are you here? Asking the students, why are they here? And I actually really, and I think we might have touched on that at the beginning of the term here, but I really want people to consider why are you at WPI, but really, why did you take this class? And I want people to consider that at the beginning, because if it doesn't line up with what we're going to do, they have a chance to switch, right? But then I asked the students, why do you think I'm here? And the typical answer was, because you get paid to be here, right? Yeah, that's not why. If I stayed here because of the salary they pay me, I would have left a long time ago. So I'm actually here because I have some passion for this manufacturing stuff, and I own a manufacturing business. I've owned other manufacturing businesses in the past. We get designs. We're a B2B manufacturing company, right? So we're a job shop. We get designs from people like yous, right? It tends to be when you go to whatever company you go to work at, it tends to be the younger engineers. I'm actually going to use slides today, I think. Somebody remind me if I don't ever turn the slides on that I'm going to use slides today. But it's usually the younger engineers, which we affectionately refer to you guys in the industry as kids with CAD. You're kids because you're younger, right? Anybody that's like 12 years younger than you is young. Anybody that's 12 years older than you is old. And I guess at the younger ages, it maybe is a narrower tolerance band. But I think by the time you get to be your age, that's sort of a true statement. Maybe how come? Don't do that. It's plugged in. It's plugged in and charging. Don't do that. Okay. Yesterday for part of the video, it was all black because the screen had timed out. When I was running around doing haikus, it was all black. Anyway, we call you guys kids with CAD because you're really good at drawing with CAD, right? Right. Those of you that expect to be a design engineer when you get a job are probably pretty good at CAD. You're pretty good at CAD? You can draw stuff? Yeah, you can draw stuff. Kids with CAD, we call them. Because you tend to draw stuff that, I'm not going to say we can't make it. I hate to use the word impossible. But you tend to draw stuff that it is improbable that we will make it. right? And so we're going to talk about some of those things that some tips and tricks, things for you guys to avoid before that comes up. But it's typically the young engineers that get tasked with doing the drawing part and the designing part. I actually skipped over that in my engineering career when I worked in for other people in engineering companies. The only, maybe I didn't quite skip over it. I had one job where I actually had to make drawings, and I had to like design the part with the solid model and then make the drawing and send the drawing to the machine shop. And I'll probably have some stories about that one job. Lucky for me, I had a very experienced engineer that I was working with that was mentoring me at that time. And he kept me from making some of these common kids with CAD kind of mistakes. But the only other design engineering job I ever did, we actually had a technical drawing person on staff. And so all I had to do was draw a sketch and hand the sketch to the drawing person and say, here, we need one of these. And it was kind of convenient because it was like an open floor plan at the place. And my desk was here, her desk was here, the CEO's desk was right here, all in one big open cubicle. So it was kind of cool. It was a little startup company. But we had a technical drawing person. So I just had to make sketches. Didn't matter if I knew the rules, all that stuff. And anyways, but we tend to have the younger engineers do this because none of us want to remember what the rules are. Us older engineers, right? We're happy to criticize you for doing it wrong, but we don't want to have to remember enough that we do it right ourselves. And so it tends to be the younger engineers that do this. When you get tasked with this, often you'll be designing like a prototype part. Does that make sense? A lot of you get on this project and they'll be like, we need to make these parts and we're going to see if it works and we're going to go out to industry. And if you're working at a big company, you may have an in-house machine shop, right? You may be designing the parts, you're bringing them down to, let's call him or her Joe, right? Joe could be a man's name or a woman's name, right? You're bringing the parts. I don't want to make the assumptions that the machinist is a man, because I guarantee you, even if the machinist is an 18-year-old woman, if she's a skilled machinist, she is a cranky old man when she's dealing with you kids with CAD. And we've all interacted with the cranky old man, right? The guy next door that yelled at us for running through his yard, playing Frisbee, breaking his window with a baseball. We've all experienced this cranky old man. So Joe is a cranky old man, whether he's a man or a woman, when he's interacting with kids with CAD. And so the first part of my presentation here, check it out, segue. I knew what was coming. Yeah, I knew what was coming next. The countdown timer was going to start. You know why it says a 10-minute timer there? Because I'm going to be ready to go 10 minutes before the class starts and get the live stream going and count down for when the class starts. And when it gets to 0, I'm going to start on time every day. And you know, the last time I taught this class, that actually worked. It wasn't always 10 minutes. I could drag the thing ahead. We need like a negative countdown timer here. All right, so I got 5 things you need to know before you talk to that cranky old machinist. This is cool. It's 5 things. You only need to know these 5 things before you talk to the cranky old machinist. Anybody think, so free A in the class if you tell me what all 5 things are right now? Anybody think they can answer that? You guys all think you're getting an A in the class anyway. You will. You'll all get an A in the class. I have faith, confidence. 5 things you need to know before you talk to that cranky old machinist. Huh. I wasn't expecting that. It like zoomed in, didn't it? I pressed the space bar and it zoomed in. Let's see what happens. Yeah. You were in my other class this morning, right? What did I say about fancy animations? They never were. Yeah. Well, I didn't say that, but that's the other reason I don't like fancy animations. All right, Command. Control 0?
Yeah, it's supposed to reset the zoom back to.
Wow. Everybody should strive throughout your life to learn something every day. I learned something today. Control 0. I was looking for and it's a Mac, so it was Command 0, but that's fine. Hey, this is easier than you think. It's only 5 things. Thing number 1, it always takes longer than you think. You guys are making something now, right? What's the first thing you learned while making something? It always takes longer than you think? Yeah. We always think, I remember answering the phone once. We used to, you swipe your ID when you go into the lab to check in. We used to make everybody pick up the phone and dial an extension, and then the lab monitor had a cordless phone they carried on their belt. And the lab monitor had to talk to you before you'd come in. I would like to go back to that some level, but it's hardship on the lab monitor. But you answer the phone, hello, wash per chops. And you hear on the other end, well, so I did my SolidWorks. And so I'm here to I guess you guys can print the part or something. And this was before we had any 3D printers in the room. Right? And so you believe, and honestly, I'm friends with the guys that founded Esprit. So the founders, they sold the company last year to a big corporation, but their goal with their software company was to make the interface, the stuff we teach you with, where you input in numbers and stuff. Their goal was to make that irrelevant. Their goal was to make it like nothing more than a printer driver. And so you drag your part in, you say, I have this machine tool, it has this tool list in it, go, and it just sends the code to the machine. And the engineer didn't have to do anything. And there's a lot of automation tools that are built in that can help you with that. But when it's a one-off prototype part and kids with CAD designed it, it will take longer than you think. So just be prepared for that and plan ahead. 5 things you need to know. Thing number 2, you actually need to know what you're making. I think this sounds obvious, but often people come to the machine shop knowing what they need, right? I need a part that moves this thing from here to here in this contraption. They know the need, the customer need they've got. They've figured that out, but they don't know how they're going to do it. They haven't finished the design. So your design may not be perfect, but have finished the design before you go talk to Joe, the cranky old machinist. You need to know why you want it to be that shape. And this is important. Period. So this is important. Now, it's important because if Joe is in a good mood, then Joe maybe will give you some suggestions about design changes. If Joe's in a bad mood or a nominal mood, I don't think it has to be a bad mood. Joe's in a nominal mood, Joe's favorite thing to do, the cranky old machinist's favorite thing to do. I was talking about this with a machinist just the other day, and he just laughed when I said it. Joe's favorite thing to do is make you exactly what you asked for, especially when they know it won't work. They can look at it and they say, I know what they're trying to do here. I can see the design intent, right? But I know that the part they've asked for is not going to function. Now, how do I know this? Because Joe's made parts for me before. And in fact, in this particular case, his name was Joe. Joe used to be the head machinist here at WPI. Maybe that's why I came up with the name Joe. Joe's favorite thing to do was make you exactly what you asked for, especially when he knew it wasn't going to work. So if you know why, and this really happens with group projects, right? So WPI is big on group projects. MQPs tend to be group projects here at WPI, right? So if your partner did the design, it's possible your partner should go talk to Joe with you. Because then when they say, could you move this hole over a ½ an inch? Or could you put a fillet here instead of a right angle corner? If you don't know the design intent, if you're the person talking to Joe, you can't answer the question. And it makes it take longer than you think it will. because you have a lot of iterations going back and forth. So you need to know why you're making it that way. Number 4, you actually need to know what material you want to use. Like early in my teaching career here at WPI, it was when I was in a mode that I hadn't actually figured out what my true job was. Has anybody ever had a job? Right? A lot of you guys have had jobs before, summer jobs, things like that. Is the job always the same as what you thought it was when they hired you? You get weeks, days, months, years. In my case, it took like 3 years for me to truly rationalize in my mind what my job was. But it's when you start, if you think it's something, that's the thing you try to do. And you actually try to force the job into the mold of what you think it is up until you realize that that's not actually your job. So I thought, the thing I thought was my job at the time was working hands-on to make parts for students and ask them to watch me. But I thought my job was to make sure that we had a flow of parts coming out of the machine shop. It turns out that wasn't my job. My job was, it's even more complicated than that. But my job was to make sure that the students who work in the machine shop learn how to make the parts. That's actually what my job is. But at any rate, so I was in this mode of making parts. This grad student comes in. He's got his drawing. He not his first trip. He'd already interacted with me, and I'd already been a cranky old machinist. And so he knew that he had to tell me like which features were important. So he didn't quite understand how to create tolerances and have the right tolerance. But at least he knew that on his drawing, his sketch, that he had to indicate which were the important dimensions. So that was cool. And he knew that it was his job to tell me what the material was. So who's had ES1310 or seen a standard drawing block? Right, we've all seen, well, we've seen some of them in ME1800 labs at least, right? So there's a little part where it says material. You guys remember that? Yeah, little part where it says material. So in there, he had conveniently written plastic, aluminum, or some other low-density material. So it tells me a little bit about design intent, right? He didn't want it to be too heavy. Now, it was 3/8 inch diameter. Yeah, I think it was 3/8 inch diameter. Maybe it was 1/4 inch. I think it was 1/4 inch diameter. It's 1/4 inch diameter and about 15 millimeters long. Does that resemble anything you've ever seen? About 1/4 inch diameter, about 15 millimeters long. See how I mixed units there? He totally mixed units in his drawing. That's why I did that. Yeah, it's because this younger generation, you haven't been as exposed as us old people. So you've ever walked down the street, sidewalk, and seen cigarette butts on the sidewalk that people flick out the window of their car when they're driving down the street? By the way, I would like to hire a sniper to shoot those people. Do they think a squirrel is going to smoke the rest of it? Anyway, the part in his drawing, it was the size and shape of a cigarette butt. I considered going out to the sidewalk and collecting some and saying, here you go. But I made them out of aluminum. So sometimes Joe will ask you if you can make a material change. Maybe there's a certain material that would be more, I hate to say the word easier to cut, but maybe there's a material that Joe would prefer to cut. And number 5, you got to remember the design part of the job is your job if you're the designer. So those are the 5 things you need to know before you go talk to the cranky old machinist. So what I want to spend the rest of today on, I think, this is where the fancy presentations break down too. I only think I know what the next slide is. Yeah, it's a recap. We're going to quickly go through the recap. Maybe not. What you're making. This is a good one. So you can have sketches, drawings, solid models. All those things work. It could be a sketch. At our machine shop, we call it napkin to part. You could sit at the bar, design your part, take a picture of it with your cell phone, send it to us, and we'll make the part. It will cost more, right? Because we have to do a lot of engineering. Or you could have a fully dimensioned and tolerance drawing for the same part, and we'll make the part. It won't cost as much as the one where we have to do all the engineering. But that's just not well, no. The problem is Joe retired. Joe doesn't work here anymore. And we try not to be cranky old machinists in the WPI manufacturing labs. So when you come to us with the whiskey stained napkin, there is some chance that we'll help you do the engineering, I regret to say. But anyway, sketches, drawings, solid models, you need dimensions, you need tolerances. In order to successfully make a functional part, you need to specify the tolerances. We'll talk a little bit about how to specify the tolerances, and we've got another lecture coming up, I think beginning of next week, where we go into that in depth. Why you're making it this way? Yeah, we talked about this stuff already. Oh, hey, this is one we didn't mention. Can you buy the part? If you can buy the part, and you only need one of them, or 10 of them, it's probably cheaper to buy it than it is to make it. I get this from MQPs all the time. Hey, this is like a part right out of the catalog. In fact, I think you took the design, I think you got the drawings by downloading them from the catalog for this part you want to make. Anybody ever done that? It's a thing you can do. You can like go to the McMaster car catalog. You can download the drawing, and then you can make the part yourself instead of buying it. And the MQP group will tell me, oh, we're doing it that way because it's cheaper. There is no alternate universe where it's actually cheaper to make it instead of buy it from McMaster Car here if you live in Worcester. In the multiverse, there's no version of Worcester where it's actually cheaper to make it instead of buy it. And when you say it's cheaper, it's because you haven't accounted for your time. So what's your time worth? What's the opportunity cost of making that part instead of buying it? You guys heard of opportunity cost? It's like the value you could have gotten if you'd done something better with your time. So like the opportunity cost of Netflix is infinite. Unless you're watching a cool documentary that you learn from. Or, what did I recently get into on Netflix? Well, there was the one with the vampires and everybody in the college campus. I thought that was pretty cool. I forget what it was called. Charmed. Charmed was pretty fun. That was the one where the college professors were playing bingo with the excuses for late homeworks. Yeah, so you get it. I'm serious. This is a valid question. How much is your time worth per hour? How much is your time worth per hour, do you think? How much did you pay for this hour? Do you know how much? Yeah, I mean, you guys collectively paid about $10,000 for this hour. It does depend on what you're doing. Yeah. There's actually a really, well, how valuable it is to you, right? Yeah, because like the time that I spend jumping in muddy puddles with my daughter, that is infinitely more valuable than the time that I spent wondering if I should go pick up cigarette butts for that graduate student, right? I mean, both, I don't know. Hey, we're going to time out. We learned yesterday that hitting cancel doesn't help, right? This is why I didn't really want to brag. Let me get ready to reconnect. Pod A, 1565, 1565. I'd be worried if somebody was stealing my computer and walking away with it and I didn't even know. All right, so time does have different values. There's actually a really great book where I think he talks about it in this book. The book's called 80-20, the 80-20 principle. Marshall's the guy's last name. It's a book about marketing. 80-20 marketing, maybe is the name of the book. Anyway, he talks about this, right? Not all time is the same value, right? You could have $10,000 an hour hours because it's the hour that you did something that was really valuable that returned that $10,000. He's talking about when you're like using your time doing marketing and stuff. And you could have negative value hours like when you're watching Charmed on Netflix, right? So not all that, but on average, what do you think your time's worth? I was expecting people to have an answer. Yeah? $15 an hour? Because if you were a work study here at WPI, we'd pay you $15 an hour. Really? You think your time's worth $15 an hour? At least. Because you could make that collecting cans on the side of the road. Definitely make $15 an hour collecting cans. How much do you think your time's worth? I think your time is worth at least $50 to $100 an hour. If you think of the discounted opportunity cost, right? Because how much do you expect to make when you graduate? More than $15 an hour, right? Right. So if you think about the future value of your time, it's definitely worth more than $15 an hour. It's probably worth $100 an hour, based on what I know of average salaries of WPI students and things like that. We talked about this stuff. Oh yeah, what are you making it out of? I had another graduate student story. It's all my good stories are graduate students because they didn't go to WPI as undergrads. So they didn't get ME1800 and they didn't get to learn this stuff, or they never sat in this lecture. All my good stories are grad students. This was an excellent graduate student story because his advisor was the department head. Right? Mechanical engineering department head should know stuff about designing for manufacturability, you'd think, right? Anyway, they needed a hemisphere to be machined out of a billet of material. He wanted to machine a hemisphere out of a billet of material. We could do that, right? You could envision what the tool path looks like. You could probably even figure out how to machine it, like how to program that tool path in Esprit pretty easily. We haven't done that in class, but I bet you guys could figure it out. If you had a long weekend, you could get the code for machining this hemisphere. If I remember correctly, the diameter of the hemisphere was 9 inches. Oh, they wanted 2 of them because I think they were making a sphere, but they understood that they couldn't like make it in one piece. And I think 3/4 of an inch was the wall thickness on this hemisphere they wanted to make. So you machine the outside, you machine the inside. So it's basically like a bowl. They only wanted one piece. It was one piece. It was a hemisphere. It was for some kind of radio antenna, right? They're like radio frequency kind of thing. For one thing, how would you hold it when you flipped it over? Any ideas? That's the thing to think about when you're designing something like this. So I got to make a hemisphere. I got a block of material. The first side's pretty easy. I clamp it in my vise, right? And I can machine, and it doesn't really matter which side is first in this case. When I flip it over, how am I going to hold it? Any ideas? You might have to make, like if you do the inside part first, the bowl part of it first, you could make the negative of a bowl that you set it down onto, and you could use vacuum to hold it down to that. That would be a way to hold it. That might be a way to do it. But how you're going to hold it is a valid question there. Oh, they had some really amazing tolerances too, like the it was the shape. It was because it also was not a spherical hemisphere. That would have been too easy. Like it was some parabola that defined the geometry on the inside. My first question was, how are you going to measure that shape? He said he didn't know how he was going to measure the shape. So I said, no problem, we can make that. Because if you don't know how you're going to measure it, I can make it. Here's the thing though. He wanted to make it out of platinum. So he wanted to, because they did the math and they needed the thing to be made out of platinum. So I said, what's the budget for this project? So I don't know. I said, well, you go look up the per gram cost of platinum, and you figure out how much volume or how much mass of platinum is just in the part you want to keep, not to mention the billet, all the waste, right? Because we could recycle the chips. And my wife used to work at Tiffany and Company, and they didn't just recycle the platinum, they remelted it, right? Because recycling, they have to send it to refine it, they lose some of the value. And so you regularly in these kind of processes with these high cost materials, you don't waste the chips, right? It was over $100 million worth of platinum that he needed. We didn't actually do that project, right? But so what if it had to be? What if it had to be that material? And it was important. What if we were making the laser thing that was going to blow up the asteroid that was going to crush the Earth, right? Sometimes you have to do it, right? What if it had to be? Well, you want to consider what's the cost of screwing up the manufacturing, right? And that's one of the reasons we do prototypes. Sometimes one of the reasons we do prototypes with different processes, like we'll 3D print the part just to see if the shape is right before we'll machine it out of platinum, gold, silver, aluminum, titanium. What's the cost of screwing up? This is the other MQP one that gets me all the time. Two things they do. Their advisor says, here, you can make it out of this piece, when that piece is totally not the correct shape to make their part out of. It's possible that, with physics, their part fits inside that shape, but there's nothing left to hold on to. There's all kinds of reasons. You get the big cube of aluminum to then slice up in two different directions, like you're slicing a cake, and then you want to take these little pieces out and machine them. It's better just to buy it in like roughly the right shape. So don't just bring some scrap material and say, hey, we want to cut our part out of this. It's not so much a big deal if you're going away to a machine shop. You typically don't supply the material when you're going out to a machine shop. You typically are telling them what the material needs to be, and they go buy the material and they charge you for that too. Sometimes the customer supplies the material. All right, and design part is your part of the job, yeah. All right, so now we're going to get to the design part. So now we stop being the Joe's taking a break, and this is what we learned. Oh, and if you talk to Joe nicely, and if you ask Joe for advice, especially if you ask for advice, when you come down with a design that is poor, if you're nice to Joe, and if you learn some of the jargon and the buzzwords, and you know that a thou is 1,000th of an inch, and then you know that a tenth is 1/10 of 1,000th of an inch. If you know these things when you talk to Joe, Joe will help you out. So what could we learn from Joe? Well, when we're the designer, I said the design is our part, right? Our business. So how does the designer tell us? They create art, so we can make a sketch, right? This is a simple sketch of a part. I'm the designer for this sketch. I did mention that I did have some formal training in engineering drawing in 1989. That's the last time I had formal training in engineering drawing. After that, it was pretty much on-the-job experience and YouTube. But here's my sketch. Have I told you enough so that you could make this part if you were the machinist, if you were the manufacturer? Have I given you enough information at this point that you could make the part? Because the designer just needs to give us enough information so that we could make the part. If you were Joe and you were inclined to be helpful, what would you ask me if I was the designer, if I was the kid with CAD and you were Joe? Yeah. So yeah, so we didn't really dimension the hole in the center, right? So that pocket that it does look like it goes through. So that through pocket in the center, is it meant to be square? So it turns out I'm the designer, so I know the answer. Yes, it's a square. Yes.
Do you want any chamfering processes on the edges?
Do I want to leave sharp edges on the corners of the part? So in a better drawing, I would have actually dimensioned that center pocket, right? And I may have made a note on the sketch, on the drawing, that said, break all sharp edges. So break all sharp edges just means put some sort of a chamfer on there. I don't care what process you use. I don't care how big the chamfer is, as long as it visually looks okay. Break all sharp edges. So because why do we want to do that? Because we don't want to cut our little fingers when we pick up the part, right? We don't want to leave burrs on those edges. Every process that goes near an edge will leave a burr. Even the chamfer will leave a burr. It just leaves a smaller burr, right? So break all sharp edges. What else is Joe going to ask me? I specified the material, right? All dimensions plus or minus 1/1000th of an inch, right? I guess I implied that all the other dimensions are inches also, right? It could have been 5 millimeters, but then the tolerance specified in inches. And if it was a WPI graduate student, that would totally be possible. But no, I implied that inches was the measurements. What else would Joe ask me? How is this part going to cost, do you think? Let's assume that the stock material that it's getting cut out of costs $3.85. This part, as drawn, with the information that Joe gathered, the part cost, the stock material costs $3.85. How long do you think? And it's oversized, so you're going to do a contour around the outside. It is the correct thickness already. All right, so we're buying the stock material the correct thickness, but we're going to do a contour around the outside, and we're going to make that pocket in the center. How much is Joe going to charge me? Any guesses? You guys have been thinking about this stuff for your project, right? How much stuff cost to make? That's one of the questions. How much does it cost to make that first part? A big component of how much does it cost to make that first part is how much does it cost to buy all the machine tools. But I also ask you, how much does it cost to make the second part, right? And so that second part is all about the cost of the stock material and the time it takes to make it, right? Any guess? $3.85 for the stock material. Yeah.
$10.
Who votes for $10? Who thinks it's less than $10? Anybody think it's less than $10? Who thinks it's more than $10? Who thinks it's more than $20? Stand up if you think it's more than $20. Stay standing if you think it's more than $50. Stay standing if you think it's more than $100. I get 3 of you still up. What do you think?
$200.
What do you think? What do you think?
I'm not sure. Are we using wire EDM for the center pocket?
That's a valid question.
That's how
I'm going to go with $125 if the inside of that pocket has to be square corners, because then I got to cut it in my milling machine and in my wire EDM. I get 2 machine tools, 3 processes maybe. If I can make radiuses on those inside corners, $70, $60. If it could be round, if it could just be a through hole, $50. What did Joe forget to ask me? I mean, Joe should have asked about the corners, inside corners. That's why I went to price. But there's another important question Joe forgot to ask. Yeah.
when you need the part back.
That's also important. But yeah, I would ask the first question. I would ask a different question just before asking that question. They kind of go together. How many do you need? And when do you need them? So if you came to me with this part and it had to be an inside square corner, 125 bucks, no problem. I might broach it. I might mill it and then use a file to clean it up. It depends on the tolerances, depends on what kind of surface finish. One part, I might not put it in the EDM. I might only just use the one machine. That's fine. 125 bucks. If you said you wanted 1,000 a day, $15 each. Because it set up a process that automates a lot of that, right? But if you just wanted 125 bucks, 1,000 a day, 15 bucks. So those are different things that Joe needs to ask. All right, we did that. Okay. As a designer, what are things you want to avoid? Ooh, this is a fancy animation. Oh, it's my kids with CAD slide. See, we did that. You want to avoid being a kid with CAD. That's like a game. You can buy it, I guess. I Googled it. What do kids with CAD do? They draw features that are expensive to make. If you didn't need those square inside corners, don't keep them, because then we can make it in a milling machine, right? And we can use an end mill to make that. If you do need those square inside corners, go ahead. Put square inside corners in there. Kids with CAD. This is a fun slide. Kids with CAD. So on the outside of a part, make a chamfer. On the inside, make a fillet. Chamfers are cheaper to make on the outside. Don't overspecify tolerances. Here's a common thing. You're making a new version of an old part. Your boss says it has to be better than the old one. You tighten up the tolerances. We're going to have a whole lecture about tolerances. That's a bad idea, though. Long depth to diameter ratios. This is a problem because the length term is cubed when you factor deflection, right? Long depth and the radius is important too on figuring out the I value. Thin walls are hard to make. Doesn't mean you can't make them, but they're hard to make. The more times it has to get held in the machine, the more different machines it has to go into, the more expensive it's going to be. Doesn't mean if you need the part, you can't design it that way. It just means think about it. Some materials take more time to machine than others. I used to think that some materials were easier to machine than others. From my perspective, for the most part, I'm just telling the computer which one it is. So as the programmer, they're all pretty much the same. But materials with low friction and low elastic modulus are hard to machine, right? We had an example in our other class this morning where their part moved because they couldn't squeeze it hard enough to get enough friction. So those things are true. I think we're done. Yeah. Cool video. Let's end on the video. Oh, there's no audio. Maybe I can make audio happen. Never mind. Find the presentation and watch the video. It's really cool. The little squid says that he's H2O intolerant. That's what the video is for. Have fun. See you guys. When do we meet again? No class Tuesday and no class Thursday next week, right? Oh, somebody, the lab group from yesterday, we're supposed to ask, when's the project due? Right? Oh, the rubric for the project. Yeah, and we were going to work it out together. You should, and you were supposed to, and it was you asked when to ask the question, right? And you said in the beginning of class we're going to ask that question. Was it him or was it you? It was you. Yeah. You guys have similar hair. Oops. Yeah, so maybe I'll publish a rubric.